together. So there's the question. Finishing up 5 points. Did you already get the answer?
No.
Yeah, what formula do we use? Anybody know? Remember the formula we use for working together problems? Yes, 1 over A plus 1 over B is 1 over together. So that's the formula. If you click on the help button for Math Excel, they give a slightly different formula. So I don't want you to get, maybe you saw, see some nods, yeah. And theirs is fine. If you got used to that and you're good with that, feel free. Mine's better. No, it doesn't matter. They're all about the same. It doesn't really matter. Either one's totally good. So, all right, so I just don't want you to be confused. So crank through that as a way of review. It was all part of my master plan. All right, 1 over 4.5 plus 1 over 10.5. And the together is x. So I don't know what the together is. That's x. We're looking for that, huh? Now, so there's our equation. We good to there? So what have we learned? We just finished, last night was the solving fractions thing. So what do you do when you got a bunch of fractions? Get rid of them. Kill them. Hitman thing. And what's going to take them out? Common denominator. Excellent. And what is the common denominator? All of them multiplied together. Right? And where do you do with it? Top, top, top. Right? We good with all those facts? So let me do that. So you might think, wait a minute, isn't there something fancy I should? Yeah, there probably is, but honestly, it's just not worth the effort. I think it'll be way easier for you just to go, look, 4.5 times 10.5 times x. 4.5 times 10.5 times x. 4.5 times 10.5 times x. Yeah, you could just do that. It'll be fine. There probably is some fancier common, but whatever. This is easy and quick. I would just simply, all three of them, top, top, top. And now cancel, right? Cross cancel and multiply what's out there. Use your calculator. You got decimals there, so I always use my calculator with decimals. Just use your calculator and get those answers. So we good? What happens in the first spot? The 4.5s cancel out, right? And what comes down? 10.5x. See how I used all the denominators, even the x? Top, 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 right? So it'll do what? Take out, Hitman, take out the denominators. 10.5 cancels 10.5. Bring down 4.5x. In the third spot, x cancels x. You guys have a calculator? What's 4.5? Well, I'll just write it down. What's 4.5 times 10.5? 47.25. Thank you. 47.25. And then these two add up to be 15. X. We good to there? Last step to get x alone. Yeah, x always wanting to be alone. Yeah, and we always do the opposite, right? Since that 15 is multiplied, we divide. Perfect. And 3.15. I think they'll take a decimal there. So does that make sense? So what did we do? We multiplied through by the whole denominator, right? All three of the denominators into one big common denominator. And you put the whole thing top, 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 and then you cancel and bring down what's left over. Cancel, bring down what's left over. Cancel, bring down what's left over. Add those together, multiply those together, divide by 15. 3.15 hours, right, is how long, and that makes sense, doesn't it? It's less than David can do it alone. Seems reasonable. Together they can do it in 3.15. See how we're getting to the truth on that? Let's see. Than Steve. So Jake can do it faster, right? Jake can do it in 6 fewer hours than Steve. Together, 4 hours. So if they work together, both Steve and Jake, they work together, it takes them 4 hours. Right? Doing it alone, Jake can do it 6 fewer hours than Steve can alone. Together, it takes them 4 hours. How long for each alone? How long for each alone? So we always start 1 over A plus 1 over B, 1 over together. Now, what do we do? Let me ask you this. What do we do in any word problem? They go blah, 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 6 fewer. X minus 6, right? 6 smaller, 6 tinier, whenever it's 6 less, 6 fewer, X minus 6, right? Fewer means subtract, doesn't it? $5, $10, and Claudia has 6 fewer, then she has 10 minus 6, right? So, yeah, so that means somewhere you're going to have to put an X minus 6, right? That's what 6 fewer means. It's not just, it's X minus 6. And somewhere else, plain X. Get the hang of it? See how that's all word problems, not just working together word problems. All word problems. They go blah, blah, blah. What do they go? 10 more. What would I do then? X, remember, you start with X. X plus 10. And the other formula, plain X. So you have a plain X, just X, and then an X plus or minus formula when they say more or less, in however they say it. They can say it in different tricky ways, right? They can say, this is, John ran 10 further. This car was 5 bigger. This house was 3 smaller. Bigger, smaller, whatever. It's plus or minus, isn't it? It's X plus or X minus, and then the other is plain X. Always. All word problems. Good thing to know. So when they go 6 fewer, I go X minus 6 and X. I know that right away. And then the together, 4 hours. So that goes right there, huh? That's making sense? So this will be 1 over 4. And then what's going to go for the A and the B? X and X minus 6. Either order doesn't matter at all. You can swap them. Doesn't matter at all. X minus 6 or vice versa, whatever. Does that make sense how I came to that setup? That's in all word problems when they say more or less. It's ag, and we're going to run into some travel ones here in a minute. So you want to get that idea. For all word problems, say more or less, it's X plus or X minus, and then there's also a plain X. Okay, common denominator. So this is a case where, just use all 3 again. Just put the 4, the X minus 6, right? Top, the whole thing. Just 4X, X minus 6. 4X, X minus 6. 4X, X minus 6. Is that making sense? Take it from there. So X cancels X. And X minus 6 cancels X minus 6. And 4 cancels 4. We good to there? That makes sense? So you cross cancel, bring down what's left over. Good? So far, so good? And then go ahead and multiply out. So, multiply out. How we doing? That's good so far. You can combine like terms on the left, huh? 4X and 4X. 8X. Other side stays the same. Good to there. Now, when we see X squared, I'm hoping to drill it deep in your mind. Remember, this is when I said somebody wakes you up in the middle of the night. X squared. What do you say? Get a 0. I hope you know that automatically. As soon as X squared shows up on the scene with an equal sign anyway, we have to get 0. Now, where do we get the 0? On the opposite side from X squared. I probably haven't said that as clear as I could. On the opposite side. So let me move over to a fresh screen if that's okay. 8x minus 24 is x squared. What was it? Minus 6x? Yeah, so let me write that out for you clearly. So when you see x squared with an equal sign, step 1 is get a 0, opposite side of x squared. From opposite side from x squared. To use better English. So the opposite side from x squared. What's the opposite side? So that'd be, in this case, the left side. So there's no hard, fast rule that it's always left side or right side. It's just always opposite of x squared. So x squared happens to be on the right, so we're going to get the 0 on the left. So how do I do this? So that's my plan, right? Everybody with me? I'm going to make the left side become 0. So how do I do that? How do I make that left side become 0? Yeah, exactly. Do the opposite of, or jump it. Is that what you're going to say? Yeah, you can just jump it. Do you like that better? Just jump it, or do the opposite. Same thing, either one you want. You just jump it. Yeah, that'll get 0. That'll put nothing there now. And remember, when stuff jumps over, what happens to it? It changes signs, huh? So it'll become a minus 8x and a plus 24, won't it? Right? Because there was a plus in front of there was nothing in front of the 8x. It's plus. Now it's minus. Is that good? So just jump everything over. It switches signs. Or you could just subtract 8x and add 24 to both sides. Same effect. Either way is good. And then gather up. What do you have there? Minus 6x minus 8. What's that? Minus 14x plus 24. There we go. So step 1 is to get a 0. What's step 2? The parentheses, the factoring, huh? Yeah. Factor with the parentheses. Exactly. Can you factor that one?
X minus 12, x minus 2.
Good. Yeah, remember how that works? You're looking for two numbers that multiply to be 24 and add to be minus 14. So what times what is 24? 4 and 6, 3 and 8, but it turns out 2 and 12. Yeah, that's the combo that can do the 14, huh? Just use your calculator if you're rusty on some of those old times tables. So both negative, right? Because negative 2 and negative 12, they add to be negative 14, don't they? And two negatives multiply to be positive, huh? So step 3, one more step. Each one equals 0. And it's just going to be opposite signs on those guys, huh? If you want to just skip the step and just jump to opposite, that's fine. I'll write it out more formally for those who want to see it. You just set each one to 0 because they're timesing to equal 0, aren't they? If two things multiply to be 0, either one could be 0, huh? That's why that's true. Jump it over, jump it over. So as we said, positive 2 and positive 12, huh? Positive. So we got two answers. Excellent. Two answers. Now, those must be, what did they ask us for in the question? How long for each person alone? Must be 2 hours and 12 hours for the two people. Careful. Remember, on a word problem, X is not necessarily the answer, but it's the key to the answer. Right? I've got keys in my pocket, but a key is not the same as a door. Right? Keys are useful for opening doors, but they are not a door. They're asking me to go through a certain door. X will let me do that, but X itself is not the answer. The answers are not 2 and 12. So where do I go get the answers? Well, what are they asking for again? They want to know each alone. What in my formula there tells me each person alone? Where is it? Yeah, it's right. It's the A and the B, which is X and X minus 6, huh? The A and the B are the two people, aren't they? And then the together, we already got that. So the A and the B are the two people. So the two people, one of them is X. That part's true. But the other is X minus 6. Right? So one of them's X was so the two people are X and X minus 6. Well, how do you do this then? So there's actually double options. X could be 2 or X could be 12. You with me? It's X. Those are both X. Neither one of those is X. I'll get X minus 6 in a second. But first off, those are both X, right? X equals 2. X equals 12. So those are both X. X is 2 or X is 12. And then subtract 6. Negative 4. Subtract 6. Positive 6. So one of them is X. So the answers are 2 and negative 4 or 12 and 6. How fast did Steve do that job, or Jake, or whoever? Negative 4. It's amazingly fast. Back in time. No. Can't do that. So that shows that this pair of answers doesn't exist in the real world we live in, right? Remember, math isn't real. It's just made up to describe things that are real. So you always got to keep one foot in reality. Math doesn't know the universe in which we live in. You can't go back in time, as far as we know anyway. You can't go back in time. There's no such thing as negative time. Math is just running numbers going, these numbers work. Math doesn't know the real world. We got to keep our foot in the real world. So throw these out, both of them, because they go together as a pair. X and x minus 6, right? Those are the two x and x minus 6. So what's the real pair? 12 and 6. X is 12, and take 6 away from that. 6. 12 and 6. Now, which one's Jake and which one's Steve? Jake is 6 hours fewer. 6 fewer. Jake is fewer hours. So which one's Jake? Jake takes 6 hours. Steve takes 12 hours. Alone. That's how long they would take alone. Together it was 4, right? When they work together, it's 4. Better than either one alone. It all makes sense now. Does that make sense? We good on that? Good? Number 8. Suppose coffee beans from 14 trees are required to produce 17 pounds of coffee, the amount each person in the United States drinks each year. You get that? And then I said suppose. I wonder if that's not true then. I don't know. You're talking to Google. Google knows. And just, so if the average coffee drinker in the United States drinks 14 trees of coffee every year. That's wild, isn't it? Anyway, how many trees are required to produce 407 pounds of coffee? Okay, so there's the question. Let me make it smaller and simpler for you. So basically, 14 trees, 17 pounds. 14 trees of coffee beans make 17 pounds of coffee. How many trees for 407 pounds? How many trees, 407 pounds? All right, I'll give it a try. This is just the two equal fractions, right? This is the easiest kind of all three word problems. This is the easiest, just two equal fractions. This is the ratio kind. You probably sense it. So just 14 over 17 is x over 407. Yeah, if it helps, you can write the words. You don't have to. I put trees on the top and pounds on the bottom. You can actually do it upside down. It works fine. Either way, whatever. Just be consistent. So I did 14 trees, 17 pounds, x trees, 407 pounds. Right? Just two equal fractions. How do you solve two equal fractions?
Cross multiply.
Diagonal, diagonal, right? Cross multiply, diagonal, diagonal, like back when we did the slope stuff. So diagonal, diagonal, 14 times 407, 17 times x. That's probably some giant number. Somebody got that? 14 times 407? 5698 is 17x. All right, good. Last step to get x alone.
Divide by 17.
Divide by that 17. So you come out clean?
No. 335.17.
335.17? I don't know if they want decimal, what they want. Oh, round to the nearest integer. So I want you to round it. So we'll just say 335. 335 what? My first physics teacher would always, if you gave an answer like 335, because they're not just math. They want to apply. He would always go 335 what, Heron? 335 what? What is that? If you just said 3, he'd go, is that dogs? That was always the same. Is that 335 dogs? How many dogs in the kennel? What is that 335? That's what he'd always say. So 335, what are the units there?
Trees.
That's trees, huh? That's trees. How do we know it's trees? Because X was on the top, trees was on the top. That's how many trees are needed for 407 pounds of coffee. We good there? So this is the easiest kind of word problems. These middle kind, ratio, just two equal fractions. Diagonal, diagonal. They'll all be just two equal fractions. So on the exam we take, when's our next exam? It's Basic 6, right? Yeah. So it's week after next on Monday. So anyway, there'll be three kinds of, I'll give you one of each. I'm very predictable. I'll give you one of each. I'll give you one ratio problem, one working together, and one travel, which we'll get to next. The number of fish in a lake. I mean, what are they going to do? Even with technology, you have sonar or something, see, they're all moving. I mean, you're going to really, like, 1, 2, 3, oh, that blip, I already got that one. That's not going to work. How do they do it? They catch, tag, and release. It's the same way they catch a bunch of fish with a net, put a little tag on them, release them, let them swim around for a couple days, and then catch again with a net, and find out what portion are tagged, and then they know what portion of the whole lake they have, and then they can use 2 equal fractions to then figure out how many fish approximately are in the lake. Now, saying all that might seem like kind of bizarre, but let me make it really simple. Let me give a really simple example, and I think you'll totally catch on. So I want this to really make sense for you, not just be some math thing. Think about if you catch, I don't know, let's say 20 fish and tag them, right? You catch them and tag them, put a little tiny tag on them and release them. And 2 days later, so you let them kind of mix around, you catch, well here, let me change. I'm going to be fiddling with the numbers here. Suppose you catch 100 and tag them. 2 days later, you catch, maybe I'm still getting confused. Wait, 2 days later, you catch 100 and, okay, wait. First day we catch 100. Keep changing my mind. I'm trying to make numbers really simple so it'll make sense. 2 days later, you catch, let's say, you catch 40 and look at them and see that 20 have the tags from the last catch. So, getting the idea. So you catch 100, tag them, let them go. A couple days they all mix around. You catch them again 2 days later. But the second time you catch 40. You pull them up, put them on the whatever, and you look them over, and half of them, right, 20 out of 40, have tags. They're the ones you caught 2 days ago. They're tagged. Half of them have tags already. So that second catch, when you grab 40, that was just totally random, right? You just did it at random. You just grab 40, pull them up, hey, half of them have tags. That'd be kind of like if I went and said, all right, who are you going to vote for in the next national election? I just went out and asked people at random, and I found out half of the people were going to vote for Trump. So what would that make me think? Half of the people I asked in my little sample of 40 people, what does that make me think about the whole population? Maybe, unless I'm in a different kind of area or whatever, maybe about half. Maybe that's reflective of the whole thing. That's what they do when they poll, right, before a national election. They ask little groups of people who you're going to vote for, and then they assume that's a little picture of the entire nation, right? So that's kind of like what we're doing here. We grab 40 and look at them, kind of like polling the fish. Who are you going to vote for, fish? We grab 40, we look at them. 20 are tagged fish. So we think, in my little group of 40, 20 of them were tagged already. So I just grabbed 40 at random, and half of them were tagged fish. Probably half of the whole lake out there is tagged fish. Since this was just random grab, and half of my little grab was tagged fish, probably about half that whole lake is tagged fish, since I just grabbed this group at random. So if half of the whole lake is tagged fish, I know how many exactly are tagged in the lake, because I did it 2 days ago, 100. There's 100 fish out there tagged. So if half of the whole lake is tagged fish, how many fish are probably in the lake? 200. That make sense? See how you can logically arrive at that conclusion? Right? Because your second grab, half of them are tagged fish. So you think, well, probably that means this is just a random grab, like me just asking people who you're going to vote for. So that probably is about that for the whole, whatever, nation, whole lake. So then half the fish in the whole lake are tagged. There's 100 tagged, so it must be 200 fish, approximately. It's not exact, but gives you a pretty good estimate, like polling does for an election, on what's going on in that lake. That's exactly how they do it. That's how they count rabbits in the field and deer on the mountain. They catch, tag, and release. Because it's too hard. They're always moving around. You can't just count them one by one. They catch them, tag them, release them, grab them at random a few days later. This is current technology that biologists use. So, what formula would we use then? Tag. So you do your first catch, tag over total, equals, and then your second catch, right? 2 days later or whatever days later, is tag over total. Your two equal fractions would be tag over total equals tag over total. What do I mean, tag over total? Well, in my first catch, I caught 100 and tagged them. So there's 100 tagged fish. In my second catch, 20 had tags, 40 total. 20 tagged out of 40 total in my second catch, huh? Does everybody see that? First catch, 100 fish, I tagged them myself, so they're all tagged fish. Second catch, 20 out of 40, tag out of over total, right? So there's my x. How do you solve for x? Yeah, diagonal. You get 40 times 100 is 20 times x. That's 4,000 equals 20x. Last step to get x alone. Divide by the 20. X equals. There's what we already knew. About 200 fish in the lake. You see, because this fraction has to equal that fraction. And 20 out of 40 is half, isn't it? So what does the bottom have to be to make this fraction half also? So they're both half and they're equal. That'd be 200, huh? 100 out of 200 is half. 20 out of 40 is half. That's the idea. Whatever you grab in the second catch, that's representative of the whole lake. Just like when you ask a group of 20 people who they're going to vote for, probably that's close to representative. Well, it's a little trickier with asking people because it depends, you know. If all your friends are a certain type of people, they probably all think the same. So it's not, pollsters have to be really careful to make sure they're getting a mix. But fish, they're always mixing around. They're pretty easy. Does that make sense? Get the idea on how that's how people, biologists and stuff count critters. So let's do the actual question then. To determine the number of trout in a lake, a conservationist catches 195 trout, tags them, throws them back, catch, tag, and release into the lake. Later, 24 are caught, 12 have tags. Hey, they're doing my same percentage, huh? Right? 12 out of 24 the second day, that's half. You just need to double that 195. We can go through the forms, though. Here, I'll write it out. So number 9 said they catch, and tag 195. Later, 12 of 24. Later, tag and release. I should say catch, tag, and release. So they catch, tag 195 and release them. Later, they catch, what was it? 24. That's right. 24, and they observe that 12 have tags. How many trout in the lake? This is just approximately, of course. All right, so what's the formula? So you probably want to put in your 3x5 card for the exam week after next. Tag over total for the first catch is tag over total for the second catch, huh? Tag over total equals tag over total. First catch, second catch. All right, can you put the numbers in there? Tag over total, tag over total. First catch, second catch. Solve for x. So, where's the 195 go? Yeah, those are tagged fish, huh? All 195 are tagged, so it goes in the top. And then 24, 12 have tags. So that's 12 out of 24. Tag is 12. Goes in the top, so my X is there. Cross multiply. Diagonal, diagonal. What do we get? 195 times 24 is 12 times X. 4680, thank you. Equals 12X. Last step is divide by 12, 390. X is 390. 390, and that's trout, huh? That way you can also distinguish, if like the fishermen wonder how many trout versus how many bass or whatever, you can just tag, you pull up a bunch of fish, you throw back the bass if you're just looking at trout, you take the trout and tag the trout, and then release them, catch again, just throw out the bass, look at the trout. You can distinguish one type from the other. If you want, white-haired rabbits versus, whatever, you can distinguish this way. It's a good little system, huh? Math comes to the rescue of counting critters. Questions on that? That good? It's my favorite kind of ratio problem. Counting critters. The speed of a stream is 2 miles an hour. The boat's 5 miles up, sometimes 9 miles an hour. Okay, let me write that out for you. So a stream speed of a stream is 2 miles an hour. And then it says a boat 5 miles upstream, same time 9 miles downstream. Upstream in the same time it travels 9 miles downstream. Did I get that right? 5 up, 9 down. What's the speed of the boat in still water? Speed of the boat in still water. So there's the question. All right. So we've done a couple travel ones, haven't we? What formula do we use for travel ones? Dirt. The dirt formula, right. Distance, rate, time. Distance, rate, time. So distance equals rate times time. Distance equals rate times time. So we're doing a little physics here. I've been doing some of this, like I said, with my daughter recently for speed of light things. So distance equals rate, and I write that out. Distance equals rate times time. So now we need some boxes. Remember how this process works? We have 2 boxes under each letter. Remember that? 6 boxes total. 2 under each letter. Now, this particular travel problem is a certain category which I want to make you aware of, and that is there's a current. So let me mention over here, when there's a current, like water moving, or sometimes we have planes flying with the wind or against the wind, same kind of thing. Wind or water, if the object, the plane or the boat, is in a current. Have we talked about this? Oh, we did. Oh, yeah. Oh, we did. Oh, great. Okay, we can save some time here. Yeah, so same direction, or you could say, let's just say downstream, and then upstream, right? So when you're going downstream, the river pushes you and speeds you up. Remember? So what do you always do? You go right into the rate boxes. What do you do? Boat. When you go downstream, it adds the current speed, or the water. So I'll call it water if you want, whatever. And then upstream, it subtracts. Right? You know what I mean? Say the boat can go 10 miles an hour on its own. When it goes downstream and the water's pushing what, 2? That would add to. That'd be downhill, downstream. Water flows down, right? From the mountains down to the ocean. When you're going upstream, then the boat speed would be slowed down by 2, huh? Because you're fighting against the current. So the current, the water speed, adds to the boat speed when you're going downhill, subtracts from the boat speed when you're going uphill, huh? So that's always your first step on a current problem, is go right to the two middle boxes and go boat plus water for down, and your two, there's not like two different boats here, two different cars or whatever. There's just downstream, upstream. So it's boat plus water. You add going downstream, subtract going upstream. Okay? And now, so that's your first step. So when you have a current problem, step number 1 is boat plus water when you're going down and boat minus water when you're going up. Okay, and then let's fill in the water. We know the water speed. 2. So get rid of this W, just put a 2 there. Get rid of that W, put a 2 there. So that becomes B plus 2 and B minus 2, doesn't it? Good to there. Okay. What can I put in next? Boat travels 5 miles upstream. Is that a distance, a rate, or a time? 5 miles. That's a distance, huh? That's the distance upstream. See which box that goes in? Right there, the distance upstream. Distance. Oh, I put it down. Whoops. Not that box, huh? Distance upstream. And then the 9 is the distance downstream. We good there so far? Is that making sense? Now remember, the last 2 boxes don't come from the words. They always come from the formula. Remember, we'll do a few of these travel ones. The last 2 boxes, so let me write this out. Last 2 boxes come from the relationship up here. D equals R times T. They're not just 3 separate letters unrelated. They are related. They have a definite relationship. D equals R multiplied by T. So now I'm trying to find T. So if you take the dirt equation and you want T alone, which is what I want, how do you get T alone in that little setup? Yeah. T will be D over R, won't it? So you get the last 2 boxes from the dirt relationship, not from the words. So the T box will be the D box over the R box. So this T box here will be the D box over the R box. This is going to be 9 over B plus 2. And this T box will be the D box over the R box, 5 over B minus 2. Does that make sense? How I got those 2 boxes? The T is D over R, huh? So it's left divided by middle, and left divided by middle. Because T is D over R, according to the dirt formula. Is that good? Now, step 3. Last 2 boxes equal. Now, not always. Sometimes it's more tricky. You probably remember. But in this case, why would these 2 boxes have to be equal? That's what I want. I'm going to bring them out, and I'm going to write equals. Why? Why do I know they're equal?
They're the same distance.
Same time, huh? Those are time boxes, aren't they? They're underneath T. So they represent time. And what did it say? Same time. Equal time. Right? That trip upstream, that trip downstream, the boat made those trips in same time. Went further downstream because he goes faster, huh? In that same time. But if the times were the same, the time boxes have to be equal. Same. Equal. So we can solve that now. Can you cross multiply? Yet again. And solve for B there. That'll be the boat speed, which is exactly what they want. Okay, so we go diagonal, diagonal. And then we distribute. Boom, boom. 9b minus 18 is 5b plus 10, right? Okay, and how do we solve? This is not an x squared, is it? So we don't have to worry about all that. Get a zero, none of that, right? That's just when you have b squared or x squared. I don't have that. I just have regular b. Nice. So what do? Get rid of the lower one, huh? Remember when you have the b on both sides? Yeah, we got to get it alone by getting rid of the lower one. So who's the lower one? Yeah, the 5b. So get rid of the lower one. Whatever you do one side, you have no choice. Do the same thing to both sides. And we get 4b minus 18 is 10. Next step, add 18. 4b 28. Last step, divide by 4. B is what, 7? The boat can do 7 miles an hour. That's the boat on its own. See what they said back here? Still water. Why did they ask speed of the boat still water? They mean without any help from the water. Just still like on a lake. You know, what can the boat's engine do on its own? That's exactly what this answer is. That's the boat on its own, without being sped up by the river or slowed down by the river if it goes against it. 7 miles an hour on its own. That's the boat's speed in still water. Are we good? Questions on that one? You want to try one of those? Feel like you can do that? All right, there you go. So barge can go 6 miles an hour in still water. What does that mean? Barge, still water. No help. That's the barge alone, right? That's the B. The boat, the barge. That works. Alone. And then 25 miles upstream, 25 miles downstream in a total time. Notice, doesn't say same time anywhere this time, does it? Total time. All right, so anyway, you know what to do, right? Start with the dirt. Write the dirt formula. Okay, let me dive in and help you. So it's the dirt formula. These are hard at first, aren't they? Aren't these difficult? You know they were difficult for me. Is that helpful to you at all? I don't know if you think math teachers are just born right out of the womb. No, these seem... my teacher in high school messed up on one of these, a log going down the river one time. I remember talking to my little friend on the phone. See, these are too hard. Mr. Allison messed up. This is ridiculously hard. This is too... I thought we could boycott them or something. I didn't know what I thought we could do. But if you do... You know, math and science, it's really hard at first. It is. But then if you make it through... And with some help, YouTube's help, tutors, whatever, make it through and then try it again later. It makes so much more sense. I'm experiencing that right now as I'm doing physics with my daughter. It's very painful for me. The first time her and I worked through things, I'm like, why are they moving, you know, da-da-da-da-da. I used the Chegg. I don't know if you know about that website. That's where you pay a service and they give you answers. They help you because I need help. I can't figure these problems out. But once we get the answer and I look at what they did, I go, oh, yeah. And then the second time, like when I help her review before she takes an exam, it's just like, for both of us, we're both like, oh, this is so easy now. You just move the thing. Why did we ever have trouble with this? That's just that it reminds me again the nature of learning math and science. It's terrible at first, but you've got to take that second look. You really do it once and then do it again, especially before an exam. That's why I give practice exams. So I know these are hard, but they will make more sense if you battle through them and try them again. All right, remember what I said, and always use my steps, my recipe steps. What was the first step? When you're doing a current problem, is to do that, right? Follow those recipes I'm giving you. They're there to help you. So put B plus W and B minus W in the middle two boxes. So let's do that. So B plus W and B minus, and the plus is when you're going downstream, because it adds to your speed when you go downhill, downstream. And upstream, it subtracts. The minus is because the water subtracts from your speed, right? Always start that way on these current problems. Okay, now let's go from here. The barge is 6 miles an hour. 6 miles an hour. Is that a distance rate or time? Miles per hour. That's a rate. That's a speed. Yeah, that's the barge speed. Where's that go? That's the B. That's the boat. The barge is the boat. This becomes 6. This becomes 6, doesn't it? 6 plus W, 6 minus W. Good? Last time they gave me the water speed. This time they're giving me the boat speed, and they want me to find the water speed. See the difference? Next fact. 25 miles upstream. Is that a distance, rate, or time? Miles is distance, right? Upstream distance. And the down is the same. I've got 4, but remember, we always get 4 boxes from the words. How do I get the last 2 boxes now? Yeah, left divided by middle, huh? Remember back here? Right? Last 2 boxes is D over R. D over R. Left divided by middle, huh? So I go, okay. So left over middle, 6 plus W. And left over middle, 6 minus W. Everybody good there so far? See how it's very similar to the last one? Starting to be more of a repeating pattern. That's how it is. It's terrible at first, but once you get the pattern down, you're like, oh, okay, I get the hang of their pattern. But it takes practice. Okay, so now, is everybody good to there? Now we're supposed to remove those 2 boxes. And what? Well, last time I set them equal, not this time though. Because last time they said same time, didn't it? Right, let's look back. It's a lot of what you do when you do math science. You want to compare problem versus problem and look at the differences. That's how you learn. Last time it said same time. So I set them equal. Equal means same. Same means equal, right? But now they're not saying, I can't put equals there. They're not saying same time. What are they saying about time? Total time, 15 hours. How do you total 2 things? Add them up, and it equals 15. The 2 time boxes must add to be 15. Total of the 2 boxes is 15. See the difference? And now we have to solve that, which is a pain. This is really hard. After all that hard work, now we've got a bunch more hard work. And I'll tell you in advance, it's going to become a W squared equation. Then we got to do the whole W squared thing where we get a 0. Then we got to factor. Then we got to get those in. Then we got to plug back in. This is a really long problem. But super instructive. What you want to do is do this again later on your own. You want to take out a blank piece of paper. This is what you should do when you get to the Math Excel question. Take a blank piece of paper. Try to do it top to bottom. If you can't get it, look back at the YouTubes and figure out what you did wrong. And eventually get it right, and then try it again top to bottom. Make sure you can do it top to bottom. That's what I had to do to make it through math science. I just had to do certain problems just again and again and again, looking at my notes, looking at help, going to my teachers, until I could do it on my own. Then it was mine. When I could do it on my own, top to bottom, with no notes. But that took hours of note looking and help getting. All right, so let's go solve this equation. So here we go. So 25 over, what was it? 6 plus W. Plus 25 over 6 minus W. Equals 15. All right, so how do we solve? We've been doing lots of these fraction things, huh? What do you do to solve a big old fraction thing? Yeah, all the denominators put together, top, right? Now, is the 15 a denominator?
No.
He's not under a bar. So he's not part of the denominator issue, right? So it's just these guys. So what do you do with them? Put them in the top. 6 plus W, 6 minus W. 6 plus W, 6 minus W. 6 plus W, 6 minus W, right? The whole common denominator, all the denominators together, top. Isn't that what we always do when we got fractions? Here's my equal sign, my wall of separation. So now what do? You cancel and multiply what's left over. Cancel these 6 plus W's, what's left over? 25. 6 minus W. Plus, cancel the 6 minus W's, what's left over? 25, 6 plus W. That good there? On the right side, is anything going to cancel? No, there's nothing under the bar. Only things under the bar cancel with things at the top, huh? Everybody seen that difference? So on the right side, what do you got to do? You got to FOIL all this out. So I'm going to leave the 15. Everybody watching the right side, this is tricky for a lot of people. On the right side, I'm going to FOIL this out. I'm going to leave the 15 sitting there for a minute, and I'm going to FOIL this out. So I'll get 36 minus 6w, boom, boom, plus 6w minus w squared. See what I did there? I just FOILed that out. Now, and then I'm going to distribute on this side. 6 times 25, 6 quarters, $1.50, right? $1.50 minus 25w, boom, boom, plus $1.50 plus 25w equals. The other side, these two will cancel, won't they? So we have 15 and we have 36 minus w squared. Distribute, distribute. I can't do that. What's 15 times 36?
540.
540. Other side, these guys cancel. 150 and 150. 300. Just been gathering a bunch of like terms and foiling things out. We okay there? Now, w squared is there, huh? And what have I always told you about w squared? Get a 0. I'm going to change my mind now. There's actually an easier way to do this one because there's not a regular w. So let me give you a new game plan. When we have w squared and no w to the first, like no regular w, you know what I mean? See, if I had a regular w there or somewhere, I would just do what we normally do. Get a 0, factor, all that. But if you just have x squared, let's just say x squared. If you just have x squared, or maybe I'll write it over here on the other side. If you just have x squared and no x to the first, it's actually easier. You don't have to do that hard work. You can just, instead of getting a 0, just get x squared alone. And step 2, put the root and the plus or minus root. And you're done. These are actually easier because we don't have a regular w. We just have w squared. If you have w squared and regular w, yeah, you got to do that whole 0 factor, all that stuff. But if you just have w squared, no regular w, don't work so hard. Just get that w squared alone. So he's over here saying, I want to be alone, please. So get rid of this 540 and get rid of this minus 15 so that I may be alone. I'm a big loner. So first off, we can subtract the 540, right? And that's gone, and that'll be what? Minus 240. Good so far? And now, what do we do to get w squared alone? Yeah, divide by negative 15, because it's multiplied by the negative 15. It's the opposite. To 16. W squared is 16. Positive, right? Because two negatives make positive. See how nice that is? So get the x squared alone, we did. And now put a root and a plus or minus root. Really, you can forget about the plus or minus in this case. Because normally we do plus or minus. So we would get w is plus or. What's the square root of 16? 4. This is water speed, right? It can't be negative. Right? Remember, math doesn't know about the real world. So it's just positive. 4 miles an hour, that's the water speed. We're done. Is that good on that one? That was a hard one, huh? So that's a good one to go through in the Math Excel homework and really make sure you know it. All right, I better move on. For your good, questions I can answer. And okay, I know we move fast in here. That's why. 13. So speed of a moving sidewalk airport, 9 feet per second. Person can walk 24 feet forward. In the same time, 19 feet on the non-moving. Okay, so you know those airports have moving sidewalks. So let's see, what is it? Speed of sidewalk is 9 feet per second. Moving sidewalk is moving at 9 feet every second. Person can walk 24 feet forward. Person walks 24 feet forward in the same time. Person walks 24. Oh, on the moving sidewalk in the same time as 19 on the non. Forward, I should have said, on the moving sidewalk in the same time. There's same time. You know we're going to set 2 times equal, huh? He walks 19 feet. Was it 19? On non-moving sidewalk. At what rate would the person walking on the moving sidewalk? At what rate does he walk on a non-moving side? I don't know if I made this any smaller. I tried to cut out some words. Again, I need them all. All right, a lot of words. So the deal is, so is this like a boat in the water? It is, right? When you get on a moving sidewalk, that's like being in a river, right? The water's moving. The sidewalk is moving. So if you get on the thing and you walk also, then that speeds you up. And if you do like what some of those kids do and they turn around and they walk against the sidewalk, right, then the sidewalk slows them down. Or you can get off the sidewalk and just walk your normal speed, huh? Okay, so let's set up our dirt equations. Okay, now, so this is a current. It's got, the moving sidewalk's like a current. It's the flow of the river, right? So what's our first step in every current problem? Yeah, right in the middle. Boat plus the water, boat minus the water. The plus is downhill, downstream with the river. The minus is uphill, upstream against the river, right? Slows us down, subtracts from our speed. Let's pretend it's a boat in the river. Same idea. Good so far? This making sense? Now let's go through it. The moving sidewalk moves at 9 feet per second. Is that a distance, a rate, or a time? That's a rate. It's how fast, huh? 9 feet every second. That sidewalk goes by 9 feet every second. So where does that go? What is that? Is that boat or water? What is that?
Water.
That's the water. That's the river. The river is the sidewalk, huh? So that's our 9. That's our 9. The person walks 24 feet. Is that a distance, a rate, or a time? That's a distance. Now, they walk 24 feet on the moving sidewalk. Okay, which distance box does that go in? On the moving sidewalk. Down. That's downhill, right? That's like going with the river, right? You're going with the flow. That adds to your speed. That goes right there, doesn't it? Does that make sense? When you're walking on the moving sidewalk, it's speeding you up, isn't it? It's adding to your speed. There's whatever speed you do, Carl, not the boat, you're the boat, plus, and then that's how far you go on that. And then it says, in the same time, he walks 19 feet on the non-moving sidewalk. Here comes the wrinkle, the curveball. 19 feet on the non-moving sidewalk. You ready? They're throwing us a junk pitch here. Are you ready? There's a trick. This is a curveball. You watch baseball? My son is just starting freshman level high school baseball now. So it's when the pitchers can first throw actually junior high was the first curveballs he saw. Up to then, Little League, it's all fastballs. You just get your timing down, you can hit. But all of a sudden in junior high and now high school, the pitchers can throw curveballs. It's kind of funny to watch the hitters struggle. I yell out to my son sometimes whenever he gets 2 strikes, or anybody gets 2 strikes, that's when the pitchers go to the curveball. I don't know why the little high school students can't realize this. It's so obvious. Yeah, it's all yelled out. John, 2 strikes. Curveball's coming. I mean, I'm sure everybody heard me. I have a loud voice. Everybody heard me. Nevertheless, here comes the curveball. Woo! So you got to be ready for that thing. So this is a curveball. The curveball's coming. They're doing something strange. What are they doing strange? 19. Does this go here? Well, non-moving. What's this?
Still water.
Yeah, they're talking still water, non-moving. The minus is if the person do what the kids do and they turn around and they walk against the sidewalk. That's not what's they're not saying the person walked against that. It's not going to, that'd be if you're going against the sidewalk and it's subtracting from your speed. Right? Like the boats that went down river and then turned around and went up river. The difference here is we're going down river with the moving sidewalk, 24, and then stepping off the moving sidewalk, no current, and walking 19. You see? They changed the game a little bit. So what does that mean? Get rid of the 9 altogether. It's just boat speed. It's just boat speed. No plus or minus. No sidewalk at all. No moving sidewalk at all. No plus 9, no minus 9. Just your boat speed, or that's your person speed, right? Does that make sense? See the curveball they're throwing? The rest is the same. Now that we had it. What would you do next? Yeah, left over middle, right, you divide 24 over B plus 9. Left over middle, 19 over B. Take those boxes out, right? And what does it say about time? Same time. So they're equal, cross multiply, da-da-da. I'm going to move on with another problem. We good there? You'll find the boat speed, or that's the person speed. But see, the trick was they didn't give me with the sidewalk and against the sidewalk. They gave me with the sidewalk and then no sidewalk, like still water, is what they did. So that second is just B. That second rate is just the boat speed. They're tricky.
You're not going to do that.
They're throwing curveballs. Well, if I give it to you in the homework, isn't it fair game then? You've seen that pitch. You're ready for it, right? There's 2 strikes, Claudia. Be ready. I'll yell that out in the middle of the next exam. Claudia, 2 strikes. Be ready. Steamboat travels 18 kilometers per hour faster than a freighter. The steamboat travels 114 kilometers at the same time the freighter travels 78. Any mention of current?
No.
Nothing. This is not a current problem. Right? There's no mention of with the river, against the river, with the current, against the current. There's no current here at all. It's just a normal dirt problem. So what, can you tackle it? Just a normal dirt problem. Looks like a change-up pitch, I guess. We're used to the fastballs. All of a sudden, they slow down the ball. All right, all my analogies are baseball. I'll try to baseball season. So I just have time for the setup, then I better get on to the next section for you. Make that a little smaller here. So we still have 6 boxes, but there's no boat plus water, boat minus water, none of that, right? There's no water adding to our speed or subtracting when we go against it. There's none of that. So, and there's no upstream, downstream. So what do I put on the left? What are the 2 things instead of up and down I write? Steamboat and freighter, huh? You with me? There's a steamboat and a freighter instead of a single boat with the current and against the current, with the wind and against the wind, with the water and against the water. So steamboat and freighter. So try to get 4 boxes from the words, same kind of thing. Get 4 boxes from the words, the last 2 from the dirt relationship. So what do we got here? The steamboat is 18 faster. At kilometers per hour. Is that a distance, rate, or time?
Right.
We're talking rates, right? That's like miles per hour, but it's kilometers per hour. It's faster than the freighter. What am I going to do with that? Exactly. Faster's like saying more. It's like they just said blah, 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 18 more, 18 bigger, 18 larger. X plus 18, huh? See how this is the same thing as that other word problem we did? It's like whenever they say more or less, that's X add for more, subtract for less. So the steamboat is 18 more, faster, huh? 18 more. So the steamboat, and this is what? Rate. This is going to go in the rate box because that's our speed. So steamboat rate right here, X plus 18, right? And then whenever there's an X plus or minus something, what else is there also? A plain X, which will go right there. Right? Because the steamboat is 18 faster than the freighter. So the freighter's X, steamboat's X add 18, right? Does that make sense? See how that's the same thing in every word problem? They go more or less. Just X add, X subtract. The other box is X, okay? What else? Steamboat travels 114 kilometers at distance, rate, or time. That's a distance for the steamboat distance. In the same time, like to see that? The freighter does 78. There's the distance for the freighter. We've got 4 boxes. You know the drill. Can I just go dot, dot, dot? This will just be one left, over middle. See how we just do that every time? It's getting easier. Like I was saying about the physics, getting easier once you do them, kind of same thing every time. Right? See the pattern, getting the hang of the pattern. Math, science, it's all just the pattern, which is really hard at first, but then after you get the hang of the pattern, they're pretty predictable, right? There it is. I'm going to diagonal, diagonal, dot, dot, dot. Is that good? Because they're same. They're equal. So no current in them. So is everybody okay with those word problems? Spend some time. I think you can definitely do those with some practice on those. Same pattern every time.